Hello friends, today we will discuss about the backpropagation calculation in artificial neural network. So our aim, like in feed forward network, in my previous video I have discussed about the how to calculate your the error, overall error or loss, right? So you have calculated the overall error by using this method, using the input, using the weights, and calculating for each node in the hidden layer and the output layer the input and output, and at the end you derived by the mean square error function what is your overall loss or error. So now you derived this is your overall loss or error. So now we want to minimize this. So to minimize this, can I change my input? No, I cannot change my input. Can I change my target output? So target output, if it is 0 or target output if it is 1, I cannot change that as well. So what I can change is my weights and the bias. So I will calculate, so for each layer I will calculate some of the weights, how it can have some new value so that the error will be minimized. So I need to minimize this loss or error. First thing is how to calculate the new value for, let's say I will calculate for W9, W10, W11, W12. So I am doing the back propagation. I will explain why I am doing the back propagation, but I will start. So if it is the L here, L is equal to the, you can say like half of Y actual minus Y target whole square for all the Y values. Okay, so L you have derived here. So now I will calculate for the first layer which is nearer to the output, what will be the value of these weights, the new value of these weights. Then I will calculate for the next layer, what will be the value for, let's say these two I will calculate. So I will explain why I just take this set, and then at the end I will check for this. So I will go for W1, W5 and W6 in the next layer, and W9, W10, W11, W12 for the next layer. So this is layer 1, this is layer 2, and this is the layer 3. So that's how we will calculate. So first I will explain how the things are calculated. So don't go by these, if you cannot see these values, don't go by this. So I have already written in this sheet. So you can see all the input value, all the weight value, and all the hidden layer input and output is calculated, and the output layer, this is the targeted output, and this is the output input for those output, and this is the actual output. Okay, so now I will explain how you can calculate the new weight value so that your loss will be minimized. So let's explain it with the gradient descent. So what is gradient descent? So that means you are calculating the what will be the new weight value if loss is the function of weight. So you know the loss is the function of weight and the bias. Okay, let's talk about the weight. I will not calculate the bias. This process is same, just let's restrict our discussion to the weight only. So if we plot this in the 2D graph, so you need to reach this point where there is no slope. So you need to move in the direction opposite to the gradient, right? So here if you start, if you have some W value at this point, so where you need to go? You need to increase the W value to reach this point, right? So the slope is here in the opposite direction, so you need to move back. So that's why W new is equal to W old minus the step size, and step size is calculated by the learning rate. Learning rate is actually how fast or how slow you want to come from this point to this point, okay? And then slope. So slope is calculated by the partial derivative. So taking all other variables as the constant, we will have the derivative of L or the error with respect to that particular weight, okay? So now why this minus symbol? Because I need to move in the direction opposite to the gradient. So if you have this point, so you need to move opposite to the gradient. If you are in this direction, you need to move opposite to the gradient. So W2 will decrease the value and W1 will increase the value. You can start with any random number and then eventually you can point to this value where the W new is equal to W old. You cannot have further corrected value of the W so that your loss is minimized at this point. So derivative is delta L with respect to that particular weight, and negative is because you are moving in the direction opposite to the gradient, and then you are subtracting it from the W old, and that is how, if LW is the error and W is that particular weight, that is how you are deriving the new weight for that next epoch. And then if you have not, so for the first epoch you move from W1 to this point, so is your loss function is minimized? No, you have not reached this point. So that's why you are doing it for the iterations, okay? So we will calculate how you can reach from W1 to next value W1 prime. So let's start our calculation. We will be heavily using the derivative function here. So let's start. So I will use these calculations what we have done in the feed forward, and next I will calculate the. So you already know what is your W old value. So what is the unknown factor and the learning rate as well. So you know that learning rate is 0.1 in your case, okay? What is unknown to you is this derivative, okay? So the slope value. So let's say we calculate it for W12. So we are back propagating, okay, starting from the layer which is nearer to the loss or the output. So how you are calculating it, pay attention, this is so important. You will be having a thinner neural network from this weight to the output. So from W12 you are reaching Y2, and from Y2 you are reaching delta Y2 or sigma Y2, sorry, and then you are reaching actual the L value, right? So if I just draw it here, so this will be like W12 and then it is participating in y2, and then it is participating in sigma of y2 and then to the L. Okay, so applying this chain rule, we can write this as delta L and then next delta sigma of y2 into delta sigma of y2 and then delta y2 and then delta y2 and delta w12. So now what is delta L, delta sigma y2? So delta L by delta sigma y2 is equal to L is equal to sigma y1 minus o1 whole square plus sigma y2 minus o2 whole square into half. So this is your L value, right? So you have delta sigma y2, so it will be 2 by 2. So derivative of x square with respect to x is equal to 2x. So it will be 2 into half into sigma y2 minus o2 is equal to sigma y2 minus o2. Okay, so this value would be 0.54 because O2 is, it is 0.58. Yeah, be cautious when you are calculating. So 0.58 minus 1 is equal to minus 0.42. So I will write as minus 0.42 into, now I will calculate this one. So this is calculated by the derivation of the activation function. So delta of sigma y2 derivation function with respect to any variable will be like, let's call it as x, delta of sigma x by delta of x is equal to sigma, you know, 1 by 1 plus e to the power minus x, and you need to have the derivative of it. So it will be e to the power minus x by 1 plus e to the power minus x whole square. Now it can be written as e to the power minus x 1 plus minus 1 by 1 plus e to the power minus x whole square is equal to 1 by 1 plus e to the power minus x taken common, and then 1 minus 1 by 1 plus e to the power minus x. So now you know 1 by 1 minus 1 plus e to the power minus x is equal to again sigma of x, and this is 1 minus sigma of x. So this derivative is actually sigma x into 1 minus sigma of x. So what we have actually is sigma of y2. So it will be like delta of sigma of y2 by delta y2 is equal to sigma of y2 into 1 minus sigma of y2. Sigma of y2 you know already 0.58 0.58. So it is 0.58 into 1 minus 0.58 is equal to 0.58 into 0.42. Okay. Now, what is the last one? Okay. So the last one is delta y2 by delta w12. So it will be delta of delta w12 y2 is equal to, you know from the photo, y2 is equal to w12 into sigma of h22 plus w10 sigma of h21 plus b2, right? So this is, now you have everything partial derivative, so everything is constant apart from w12, so it will be, other will be nullified, only you have sigma of h22. So that is sigma of h22 is equal to 0.818. So now writing them here is equal to 0.58 into 0.42 into 0.818. So this actually is, if you calculate, minus 0.0836. Now you have delta L, delta W12. So what will be the new value of W12? So I will write as W12 prime or W12 t minus t plus 1, whatever way you can write, minus learning rate into delta L, delta W12. So it will be W12 is equal to 0.3, learning rate is equal to 0.1 into minus 0.0836. So it will be 0.3 plus 0.00836. So it will be 0.30836. Same way we will calculate for delta L, delta W11. So it will be W11 to where it is going, Y1. Now sigma of Y1 to L. Okay. So applying the chain rule, what we will have is equal to delta L by delta sigma Y1 coming from there into delta sigma Y1 by delta Y1 into delta Y1 by delta W11. So now the same way how we calculated this delta L delta sigma y2, we will calculate the delta. So it will be same as this, right? So delta L delta sigma y1 is equal to, same way we can write sigma y1 minus O1 is equal to 0.54 minus 0 is equal to 0.54. Now the second one you see is delta sigma y1. So now you have second one delta sigma y1 by delta y1. So applying this derivative formula, you know that it will be sigma of y1 into 1 minus sigma of y1. So what is it? What is sigma of y1? Sigma of y1 is equal to 0.54 into 1 minus sigma of 54 is equal to 0.46. Okay. So now what is the third part? So third part is delta y1 by delta w11. So delta y1 by delta w11 is equal to delta of w11, y1 is equal to, you know, w11 sigma of h22 plus w9 sigma of h21 plus b2 is equal to, taking all the things constant, so it will be sigma of h22 is equal to, what is sigma of h22 is equal to 0.818. So now the overall value will be .54. So having this one as 0.54, so it will be 0.54, okay, and this will be 0.54 into 0.46 into 0.818. So overall, if you calculate, it will be 0.1097. So now what will be the next value of W11 is equal to W11 minus eta of delta L by delta W11 is equal to 0.2 minus 0.1 into this value 0.1097 is equal to 0.2 minus 0.01097. So it will be approximately 0.189. So now let's calculate for the other two values. What is the next value? I will calculate for delta L delta W10 is equal to, you know, so W10 is contributing to Y2 and Y2 is contributing to sigma of Y2 and it is contributing to L. So applying the chain rule, we'll have delta L by delta sigma of Y2, delta sigma of Y2 by delta Y2, delta Y2 by delta W10. So now you don't need to calculate it again, you can use it. That's why I have taken these weights, so you can reuse. So what is delta L by delta derivative of L with respect to sigma of Y2? So it will be 0.42 minus into, what is this one? So this is 0.58 into 0.42. What is this one? So this is not calculated. So this again we can use that delta of Y2 by delta W10 is equal to derivative of W10 sigma of H21 plus W12 sigma of H22 plus B2, right? So this is now taking everything else as constant, so this will be sigma of H21. So what is sigma of H21? So you have 0.786. So putting that value here, so it will be 0.786, right? So if you calculate, so it will be minus 0.0804. So what will be the next value of W10? Is equal to W10 minus derivative of L derivative of W10. So it will be 0.1 minus 0. I have forgot the learning rate, 0.1 into minus 0.0804. So it will be 0.1 plus 0.008. So it will be 0.108. Now next we'll calculate for W9. So it will be applying the chain rule. So derivative of error with respect to sigma of y1 into next it will be sigma of y1 derivative of y1 then derivative of y1 with respect to w9. So now you already know what is the derivative of y1. So it will be 0.54 into, so this you also know, so it will be 0.54 into 0.46 into this part you don't know. So let's calculate. So this part can be calculated easily. So instead of, so delta W9 will be same as, I am doing repeated mistake on writing W9, so please pardon me. So it is W9 sigma of H21 plus W11 sigma of H22 plus B2, right? So taking everything else constant, so it will be sigma of H21. So now you know what is sigma of H21. So sigma of H21 is equal to 0.786. So it will be 0.786. If you calculate, this will be 0.1054. What will be the next value of W9? So this is the formula. So W9 is 0.9, learning rate is 0.1 into 0.1054. So it will be 0.9 minus 0.01. So it will be 0.89 approximately. So now, just to recap, you have calculated for W12 next value and derivative of L with respect to W12 and W11 and W10 and W9. So you have now completed this layer, okay? So let's say this layer is completed because it has a direct. So this lean tree is completed. So next we will move to the next layer where it is contributing both to the both nodes, right? So if you calculate for W5, it is actually contributing to H21 and sigma of H21, and further it is contributing to both Y1 and sigma Y1 and Y2 and sigma Y2 and then L. So let's draw it. If you draw it, then that will be very clear.